Imagine staring up into a perfectly clear night sky, where stars twinkle peacefully, and the universe feels vast yet calm. But then, you notice something alarming, an object streaking across the sky, moving fast, coming straight toward Earth. Now imagine that object isn't a shooting star or a satellite but a massive asteroid on a collision course with our planet. It's not a sci-fi scene from a disaster movie. It's a scenario that has actually played out in Earth's history. Just ask the dinosaurs. Their extinction was caused by a colossal asteroid impact, and there's no reason something similar couldn't happen to us. That terrifying possibility became real again late last year, when scientists discovered an asteroid named 2024 YR4. At first, calculations showed it had the highest probability of hitting Earth ever recorded. The chances were alarming. Although further analysis reduced that probability significantly, the danger hasn't entirely passed. We're still not completely safe. So what do we do when we see potential doomsday racing toward us? Wait and hope? That's not good enough. What if, instead, we could change our fate, rewrite our ending before it ever begins? That's exactly the kind of question NASA has been trying to answer. You may have heard of the asteroid belt, a region in our solar system packed with rocky objects. It's located between Mars and Jupiter and formed from the remnants of the early solar system. These rocks were trapped in a massive gravitational struggle between the Sun and the gas giant Jupiter, with Saturn occasionally influencing the chaos. Due to these forces, the materials in that region never had a chance to form a full-fledged planet. Even if they had, all the combined matter in the asteroid belt would only equal a body 1/4 the size of our moon, barely significant on a cosmic scale. Asteroids are basically leftover building blocks from the time when planets were forming. But don't underestimate them. They're not just space debris. They hold immense value both scientifically and economically. Studying them could help us better understand how our solar system, and possibly life itself, originated. These space rocks could also be mined in the future for resources like metals and water, potentially supporting deep space missions or even the next wave of technological progress back on Earth. Most asteroids are quite small, only a few meters across, and are so distant and dark that they're invisible to even our most advanced telescopes. But others, like Ceres, are enormous. Ceres is the largest object in the asteroid belt, stretching over 1,000 kilometers in diameter, and is so big it's classified as a dwarf planet. This single object alone makes up about 1/3 of the entire asteroid belt's mass. When it comes to their makeup, asteroids fall into 3 main categories. The most common are the C-types, which make up about 75% of all known asteroids. These are rich in carbon and resemble vast coal mines floating in space. Next are the S-types, making up around 20%. These are rocky and contain significant amounts of iron and other metals. Then come the rarest of them all, the M-types. These are like floating treasure chests, made up almost entirely of metallic iron, nickel, and even trace amounts of precious metals like gold and platinum. Just imagine, asteroids may one day become the fuel for space-based economies, mining colonies, or giant manufacturing hubs in orbit. The possibilities are endless. But not all these rocks stay in their designated zone. The solar system is like a vast neighborhood. Most asteroids stay in their own yards, the belt between Mars and Jupiter. But once in a while, one of them breaks out and starts drifting dangerously close to us. Sometimes, what enters our space isn't even from this solar system. Take Oumuamua for example. Detected in 2017, this object came from interstellar space, making it the first known visitor from another star system. Scientists were fascinated, and puzzled. It didn't behave like any ordinary asteroid or comet. It had a strange shape, didn't emit gases like a typical comet, and accelerated in ways we couldn't fully explain. Some experts even speculated it might be an alien probe, though no evidence confirmed that. Still, the event opened minds and made us realize just how mysterious and unpredictable space can be. Back here at home, though, we face threats much closer than interstellar visitors. When asteroids cross paths with Earth's orbit, they are classified as near-Earth objects, or NEOs. One of the most famous, and deadly, was the Chicxulub impactor. This NEO was around 10 kilometers in size, as big as a city, and slammed into what is now the Yucatan Peninsula about 66 million years ago. The result was apocalyptic. Dust and debris blocked out the sun, ecosystems collapsed, and the dinosaurs, who had ruled Earth for over 160 million years, were wiped out in one violent chapter of Earth's history. That event is why scientists take threats like asteroid 2024 YR4 so seriously. Thankfully, 2024 YR4 isn't as large as the Chicxulub asteroid. It's estimated to be between 40 and 90 meters in diameter, about the size of a football field to a skyscraper. But don't let the smaller size fool you. If this S-type asteroid were to strike Earth, the devastation would be horrific. A city the size of Albuquerque, New Mexico, could be completely flattened. Thousands of lives could be lost, infrastructure obliterated, and the global economy disrupted. The blast could release energy
Osiris-Rex lifted
equivalent
off
to
in
multiple nuclear
2016,
bombs.
targeting
The
a
question
near-Earth
is, will we be
asteroid
ready
called
when,
Bennu, a
not if,
carbon-rich,
another threat
C-type
emerges?
asteroid. Bennu
NASA has
isn't
been
massive.
preparing for that
It's
very
just around
scenario for
500
decades.
meters wide,
Back in
much smaller than
1996,
Eros.
they took a
But unlike
groundbreaking
solid
step with
rock
the launch of their
asteroids,
first asteroid
Bennu is a
mission,
loosely held
near
together
Shoemaker.
pile of rubble,
NEAR stands
making it
for
a
Near-Earth
risky and
Asteroid
fascinating
Rendezvous,
target. The
and the
spacecraft
was
reached
named
Bennu
after
in
Gene Shoemaker,
2018
a
and began
pioneering
orbiting
planetary
it carefully,
scientist.
studying its
target was
surface in
Eros,
detail for
one of the
nearly
larger
2
near-Earth
years.
asteroids,
This phase was
roughly
critical.
3 times the size of the Chicxulub impactor. Initially, NASA's goal wasn't to land on Eros. The plan was to enter orbit and study the asteroid from a safe distance. And in February 2000, NEAR Shoemaker did exactly that. It began circling Eros and used a suite of onboard instruments to photograph its surface, measure its gravity, calculate its mass, and assess its composition. The data revealed that Eros was an S-type asteroid, confirming it was made mostly of rock mixed with metal. Interestingly, it had no magnetic field and its surface was covered with craters and deep grooves. After nearly a year in orbit, NASA decided to take a bold step, attempting to land near Shoemaker on the asteroid's surface. Given the low gravity, it was a risky move. But in February 2001, the maneuver succeeded. The spacecraft touched down gently and continued to transmit valuable data back to Earth for weeks. If you could have stood on the surface of Eros yourself, you would have needed to be extremely careful. Its gravity is so weak that even a strong jump might send you floating off into space. It's like standing on a bouncy rock in the middle of the solar system. Many asteroids are believed to be rubble piles, loose clusters of rock and dust barely held together by gravity. But Eros was different. NEAR Shoemaker confirmed that it was a solid body, carved and scarred by billions of years of impacts. And one of the most intriguing findings was a thick layer of dust covering its surface, hinting at a history more complex than anyone had expected. This was just the beginning of NASA's mission to understand and possibly defend against these ancient cosmic wanderers. Certain regions of our solar system have always intrigued NASA, but some areas raised even more questions than answers. These puzzling regions pushed NASA to ask a bold question. What if we could send a spacecraft to an asteroid, gather samples directly from its surface and bring them back to Earth? What once sounded like science fiction turned into reality with the launch of a groundbreaking mission named Osiris-RX. This mission wasn't just an experiment, it was a giant leap toward understanding the building blocks of life in the solar system's early days, bringing real asteroid samples back from deep space. Osiris-RX lifted off in 2016, targeting a near-Earth asteroid called Bennu, a carbon-rich C-type asteroid. Bennu isn't massive, it's just around 500 meters wide, much smaller than Eros. But unlike solid rock asteroids, Bennu is a loosely held together pile of rubble, making it a risky and fascinating target. The spacecraft reached Bennu in 2018 and began orbiting it carefully, studying its surface in detail for nearly 2 years. This phase was critical, as scientists needed to identify the safest and most scientifically valuable location to collect samples from without damaging the spacecraft. Then in October 2020, Osiris-RX performed one of the most daring maneuvers in NASA history. Using a robotic arm called TAGSAM, short for Touch-and-Go Sample Acquisition Mechanism, it briefly touched down on Bennu's surface for just 6 seconds. A burst of nitrogen gas stirred up the loose regolith, allowing the spacecraft to capture particles. That brief contact was all it needed. About 120 grams of material were collected, and Osiris-RX quickly bounced back into space, leaving the asteroid's surface like a high-tech pogo stick, mission success firmly in its grip. The collected material was placed inside a secure container called the Sample Return Capsule, or SRC. This capsule was specially designed to survive the brutal conditions of re-entry. Its aerodynamic shell was lined with an ablative heat shield, ready to withstand the searing heat as it plunged back to Earth. After the successful sample collection, Osiris-RX continued orbiting Bennu for a few months while mission teams on Earth prepared for the return phase. Once everything was in place, the spacecraft released the capsule, and it began the long journey home, traveling through space for nearly 2 years. Finally, in 2023, the SRC entered Earth's atmosphere, blazing across the sky before safely parachuting into the western Utah desert. This small capsule carried something extraordinary, real material from an asteroid older than the Earth itself. Scientists immediately began examining the contents. What they discovered was astonishing. The sample contained all 5 of the crucial building blocks that can form DNA and RNA, the molecules responsible for genetic instructions in living organisms. Water, phosphate compounds, and 14 of the 20 amino acids used by life on Earth were also found. This was strong evidence supporting theories about the cosmic origins of life. But OSIRIS-REx's journey didn't end there. It has been given a new mission and a new name, OSIRIS-APEX. Now, it's en route to another asteroid called Apophis, which will pass extremely close to Earth in 2029. Although this time no samples will be returned, the mission will still provide valuable insights into the surface and composition of Apophis. Even without physically retrieving material, close-up observations will allow scientists to better understand asteroid behavior, structure, and how we might interact with such bodies in the future. The mission still holds promise for remarkable discoveries. While studying distant asteroids like Bennu or Apophis is fascinating, not all asteroid visits are welcomed. If one of these space rocks were to head toward Earth without warning, the consequences could be catastrophic. It might not end the human race entirely, but it could absolutely bring civilization as we know it to a halt. That's a risk NASA isn't willing to take. To deal with this threat, NASA developed a bold plan. What if we could deflect a dangerous asteroid just enough to change its course? That plan became reality through a mission called DART. DART stands for Double Asteroid Redirection Test. The concept was simple but ambitious. If an asteroid is detected early enough, maybe we could slightly nudge it off its path, avoiding a deadly collision with Earth. In 2021, NASA launched the DART spacecraft aboard a SpaceX Falcon 9 rocket. Its destination? A binary asteroid system consisting of a larger rock named Didymos and its smaller moonlet, Dimorphos. The plan was to crash the DART probe into Dimorphos at high speed and see if the impact could alter its orbit around Didymos. A real test of planetary defense in action. DART wasn't loaded with explosives or advanced weaponry. Its power came purely from speed and precision. The spacecraft included a navigation system, solar panels, a CubeSat observer, and an impactor. That was DART itself. After a long voyage, it reached its target in September 2022. Then, traveling at a mind-blowing 24,000 kilometers per hour, DART slammed directly into Dimorphos. The impact didn't destroy the asteroid, but it worked. It changed Dimorphos's orbit around Didymos, shortening its orbital time by 33 minutes. It was the first time humanity had ever changed the trajectory of a celestial object. The success of DART wasn't just a milestone, it was a wake-up call to what's possible. For the first time, planetary defense shifted from theory to proven reality. The message was clear. With enough time and preparation, humanity can defend itself against cosmic threats. But one key ingredient still remains: detection. You can't deflect an asteroid you don't see coming. That's why NASA is focusing heavily on detection systems. Recently, the James Webb Space Telescope turned its attention to a newly discovered object, 2024 YR4. While the threat to Earth is low, there's now a small 4% chance it could hit the Moon. To expand our detection capabilities even further, NASA is developing a mission called the NEO Surveyor, short for Near-Earth Object Surveyor. Scheduled for launch no earlier than 2027, this space-based telescope is designed specifically to hunt for smaller asteroids that are hard to spot with ground-based observatories. These tiny but potentially dangerous rocks often go unnoticed until it's too late. Once deployed, NEO Surveyor will significantly boost our ability to catalog these threats early, giving us time to prepare or deflect them. Another crucial step in
OSIRIS-REx
humanity's
lifted
growing
off in
planetary defense
2016,
arsenal.
targeting
But
a
the
near-Earth
potential of
asteroid
asteroids
called
isn't just
Bennu
limited to
carbon-rich,
danger or
C-type
scientific
asteroid.
curiosity.
Bennu isn't
There's
massive.
an economic
It's
frontier
just
as
around
well.
500
In
meters
October
wide,
2023,
much smaller than
NASA
Eros.
launched a
But
probe
unlike
named
solid
Psyche,
rock
carried
asteroids,
into space aboard
Bennu
a
is a
powerful
loosely held
Falcon Heavy
together
rocket.
pile of rubble,
Its target
making
is
it
a
a risky
metal-rich
and
asteroid
fascinating
also called
target.
Psyche,
The spacecraft
believed to be
reached
the
Bennu in
exposed core of a
2018
failed planet.
and began orbiting
Unlike
it
typical
carefully,
rocky
studying its
asteroids,
surface
this one
in
may
detail
contain
for
vast
nearly 2
quantities of
years.
nickel,
This
iron,
phase was
gold,
critical.
and other rare metals. If current estimates are even close to accurate, the raw materials on board Psyche could be worth up to $10 quintillion in today's economy. That figure is so massive, it defies comprehension. Imagine a future where mining asteroids becomes not only possible, but profitable. In theory, we could attach propulsion systems to an asteroid like Psyche and gently guide it into Earth's orbit, making resource extraction easier than ever. The Moon might look silver now, but one day we might glance up and see a golden object orbiting beside it, our first space mine treasure. Of course, that's a dream far in the future. Before we can tow asteroids around, we need a much better understanding of their structure and behavior. That's where the Lucy mission comes in. Launched in 2021, Lucy is on a 12-year journey to study the Trojan asteroids, ancient space rocks that share Jupiter's orbit. These bodies are thought to be some of the oldest, most pristine objects in our solar system. In late 2023, Lucy already completed a successful flyby of a small asteroid named Dinkinish, which turned out to be a twin asteroid system, another unexpected discovery. This encounter provided NASA with valuable flight data and insight into binary asteroid systems, helping them prepare for even more complex encounters in the future. As Lucy continues its journey, it will perform a series of flybys through the Trojan swarms, gathering data from several asteroids along Jupiter's path. Each flyby is like turning a new page in the solar system's history book. Every observation gives researchers new information on composition, formation, and even how best to land on these bodies. From learning how to collect samples to building stronger spacecraft defenses, Lucy's mission is laying the groundwork for the next generation of space exploration, and possibly the next space economy. What began as a scientific adventure could one day become humanity's greatest leap into interplanetary resource development.